So any doubts till now in the last lecture?
Nothing particular.
Should we proceed? About Cauchy sequence, Banach space, triangle, like these norms and all, Bellman equation. Or should I revise these topics if you want? Should I proceed or?
Madam, just on some basic questions, some fundamentals. The value function means V of S and Q of S comma A. Are they always dependent on the policy?
Okay. Can someone answer the question? Let's make this session interactive one.
Can you repeat your question?
Yeah, because what I don't understand is when we are talking about value based, that means value of state and value of state action pair, that is Q of SA. We always start with policy, end with policy. So we assume that we have to have a policy to start with. Then only we can compute value function. Am I correct?
For value function, do you need policy initially? Can someone answer this question? Do we need policy initially? What is policy basically?
Yeah. Yes.
Policy is mapping from state to action.
Yes. So basically, we'll get a rule that if we are in the particular state, then what action we have to perform. That will be done afterwards. Am I correct?
Yeah, like initially the probability for each action at each state should be equal. So it will be pretty random.
So basically, I'll repeat this concept maybe. So you understood the concept about policy. What is policy? We are in a particular state. We are performing an action. Then the mapping from states to action. What action should be performed? That is given by a policy. Is it clear till this point?
Yes, madam.
Yes. Now, are you having policy initially or policy afterwards?
Yeah, that is what the confusion.
Policy
To start calculating, we need policy, and also finally also we are ending with policy.
Why to start with we need a policy?
I don't know.
I mean, there has to be some probability distribution, right?
The probability distribution is there. Can we say that is a policy?
Suppose there is no policy, so all states are all actions are equal. We can assume, right?
No, there is a probability distribution.
Like we have a policy, but that is not deterministic.
Yes, yes. It is an arbitrary policy, yes. But at the end, what we are getting is the real policy, what we have to follow. Am I correct?
Oh, okay. That I understand. At the end, when it converges, we get the optimal policy. Yeah, convergent policy. Yes.
Now, what is the difference between V and Q? Can anyone answer?
V is based on state, Q is based on state and action.
Yes, he's absolutely correct. If we are in a particular state, then what is the expected return? That is value. We are in state, what is the expected return? Now, Q means I'm in a particular state and a particular action is already performed. Then what is the expected return? That is Q. Got it, or you are confused? I can explain you again. If I talk about V pi of S, that is, I am in a particular state, then what is the expected return? If I talk about Q pi, I am saying that what is the expected return when the first action is already performed? Am I correct?
Correct.
So this is the difference between V and Q, basically. And then we'll convert to an optimal policy.
So basically, the value is average of Q of SA over all the actions. Okay. So for example, we are in state S. So from S, we have a possible, let us say, 4 actions: A1, A2, A3, A4. So Q of S comma A1, Q of S comma A2, S comma A3, Q of S comma A4, all the average of those returns becomes V of S.
It's like, if I'm saying about Q, I'm saying that first action I know. That is this A1, is this A2. First action I know. I'm in the particular state S, first state, and this first action I know. Then what is the expected return? Expected reward basically, or expected return here. This first action I know. Here I don't know the first action. I'm in a particular state. This also I don't. And this may or may not be. Is this an optimal action, first of all? Can someone answer? Is this an optimal action? Like in Q, what we are taking, is this optimal? No.
Yes.
No,
Any
need not
action.
be. Need not be.
Need not be. So this is basically the difference. The first action is already there. I am in a state, I am in the first action, then what is the expected return? Okay, we'll solve the example and we'll get the more intuitive understanding about this MDP and all of these. Don't worry. So you want that I should solve the example which I have given you now only, or at the end of the lecture in the last 30 minutes? You're not audible. Okay, let's solve afterwards. Because maybe there'll be more clear understanding about these concepts and then it might be more easier. Any doubts? Should I proceed?
Yes, madam, go ahead.
Okay. So should I revise the last concept, or should I proceed forward? Assuming that everything is clear. So what is stochastic matrix? Can anyone tell me?
It has I think it is probability of each or each action in each state. So mapping. It's a
Yes. Each action in each state. Can I say that rows add up to 1? Basically, matrix.
if each state is 1 row.
Yes. So rows are adding up to 1, and basically they are non-negative, or I can say between 0 and 1, they lie between 0 and 1 basically. So here we are assuming the probability that transition matrix, that is basically a stochastic matrix. Now, what is one-step transition in MDP? What is this? Let us try to understand each and every equation in very detail, getting into depth so that everything should be clear, because we are here in this class focusing more on theory in this today's class. So what is this?
I know, but that is called immediate reward. What I don't clear, madam, if let us say you are positioned in state yes. By being positioned in state yes, do we get immediately reward or only after taking an action from state yes?
I'll take the action, then I'll get the reward. How, if I'm in a state S, I'm doing nothing. What I'm saying is, if I'm in a state S and I'm doing nothing, then how can I get the reward? If I'm doing something, then only either I'll get a reward or either a positive reward or negative reward. So after doing some action only, then only we'll get a reward. Clear?
Okay, okay.
Because if you're doing nothing, if you're in a particular state doing nothing, then there is no concept of reward or cost. If you're
But then, madam, you say value of state. What is the value of state when you're doing nothing?
value of state, okay, let's go back. I'm in a state S, I'm doing the action, then what is the reward? It is like, here what I'm saying is, the action is A here. Here the action is
No,
not.
madam, that I understand. That is Q. Q I understand. Q has a value only when you take an action. But what about just value V of S?
Can someone explain? Yes, he's asking a question. But are we doing in value function something or nothing is done and then we are getting a reward? Can someone tell me?
It is expectation of all the actions, like rewards from all the action we can get.
So basically, we'll get the reward only when action is done. Here, some action is done. We are saying that which is the best action, and then we are getting the average of that reward, basically. Sum of all the actions, as he said. Here, we are only doing action A. This is the difference between them. Action is performed here also, action is performed here also. But here, we are mentioning which action is performed. Here, we are not mentioning which action is performed. Here we are given that you have to perform A or not, whether it's optimal or not. We don't care about it. Here we are performing all the actions and then we are checking that which one will be the, what will be the expected reward there. All the actions will perform. Do you got the idea?
Yes, yes, madam.
So now can someone tell me what is this R pi? Simple reward. I can say for one transition. P pi, can I say this is the probability which will tell me where I'm going to land or which state I'm going to land? And this is basically value function here. I can say as a terminal cost here. And basically I'll get one step transition means I'll get a reward and then I'll land in a particular state and then what is the final cost there. So that is what we are getting as V pi, expected value. Is it fine? Just I have taken this terms here like V pi minus gamma, V pi, and then I have calculated what is V pi. Is it okay? Yes?
Yes, madam.
Yes.
I think everyone should be interactive in the class. Only 2-3 students are only answering the questions. Let's make this session interactive one. I am also in the learning stage. I'll also learn from you. You will also learn. So let's make it as interactive one rather than one way or only 2-3 students answering. Anyone? What is the largest eigenvalue for the stochastic matrix?
1.
And what is invertible? Like, what do you mean by invertible? Whether a matrix is invertible or not?
The determinant is
Non-zero.
so it's mean all the eigenvalues are non-zero.
Yes, same thing. So basically, I can say that whether whether it's invertible or not matrix. If matrix is invertible, there is a condition that like the eigenvalues are basically not zero here. So then we can say that it is invertible. So what do you say about this equation? Is it in like the matrix is invertible, or can you comment about anything about is V pi unique? I gave you some conditions here. You only told me.
Yeah, it is. If gamma is less than 1, I think we can guarantee that this is
Is gamma
invertible.
less than 1 or not? What is gamma first of all?
The discount factor.
So discount factor, what is the range of the discount factor?
0 to
0 to 1.
0 to 1. So obviously it is, let us take it as it is less than 1 basically. Now, what is P pi? Oh, sorry. What is P pi?
R stochastic matrix.
Stochastic matrix. What is the, okay. And let us take that when we'll multiply it, what we'll get? The largest eigenvector value, it is 1 basically. So when we'll multiply it, we'll get a value lesser than 1 because gamma is less than 1. So it is less than 1. 1 minus something which is less than 1, can it be 0?
No.
So I can say this whole cannot be 0 basically. Am I correct here?
Yeah, yeah.
Can someone tell me from the starting what is happening now? Like one step transition, how we go here? Can someone explain me?
Yeah. So we have defined our value function in terms of that we take a reward, we take a action and we get reward, and from after that time uh, we consider the value function from the next state and discount it. So now uh, we have taken the discount factor part and value the value function from the next state to the left side, and we have taken v pi common, so we got 1 minus sigma p pi delta, and on the other side is the immediate reward, and that is actually I that is identity matrix. So
Sorry, as 1. Yes.
so p pi is stochastic matrix, so its eigenvector will be maximum 1. So when we multiply by this discount factor, it will be less than 1. So even if we subtract from the identity matrix, then we'll have a number greater than 0. So this matrix will be invertible. The eigenvalue of the whole will be not 0.
Yes, yes, yes. Okay, let's proceed. So let it be some space of all value functions. And let it be some Bellman operator. Let me write, then I'll tell you. Same equation I'm writing, just I'm adding L pi. Now I'm saying that can someone explain this? What do you mean by this?
The V pi is a fixed point.
What do you mean by fixed point?
Like if we apply the operator on it, there is no effect. It will remain the same.
Can you repeat? I didn't got you what you're saying. If we apply the operator on it, then
Yeah. Then there will be no change in its value.
is it like I'm applying it and then there is no change for the first time itself?
No,
No, it will.
I think it will converge to that.
Yeah, it will converge to.
I guess you are correct. So basically it is like I apply L pi on it, it goes to some point, again I apply, then it goes to some point, and after some time it will converge, which means that it will stay in the same point. Which means that after applying V pi is a fixed point of L pi, I take and then I'm applying I'm applying it again and again, and then some movement will come that they'll not change basically. So they'll converge. That is basically Banach fixed point, or it's basically fixed point or Banach fixed point theorem. Any doubts for what is fixed point? I can come with some example if you want. Can someone tell me some examples? Yes.
Can we say one is fixed point if the operator is like square? Taking square.
If the operator is square, let us say, see. Can you tell me what you are saying? Fx is equal to x square, you are saying. Is it like that?
Yeah, and the fixed point would be one because anytime we apply it will remain one.
Okay, I apply one, I'll get one. But the function is not applied again. Okay. Are you getting me? It's like V pi, I'm applying L pi, V pi, I'm getting V pi. Then I'm applying it again here.
Okay, so we have to, but even if we like apply any number of time, it will remain one, right?
Yes.
Madam, one example, this exponential function derivative f of f dash of e power x is equal to e power x.
E power x. Okay, derivative of e power x is equal to e power x.
So
Is
that,
it correct?
yeah, I don't know. This looks similar to that fixed point.
Okay,
that-
let's take it as homework problem. Though I didn't saw any problem which are solved there. I asked some problems like the example which I have given. Can I expect this time?
Yes.
So everyone have Slack link. If someone is not having, you can write in the chat. Okay, let's go. Are they same or are they different?
Same as far as
Basically, complete normed vector space is called as the Banach space only. The other thing which I want to ask, what is contraction mapping? Yes.
when we apply some function to 2 points and the distance between them should decrease.
So basically, I have u, I have v 2 points. Then I have a function that is tu and tv corresponding to them. So now what you are saying, the distance between them can I write like this?
Yeah, k should be 0 from 0 to 1.
Yeah, yes. I think it can be included in one. Okay, is it correct? What does it mean? I have u point, I have v point. The function corresponding to them is tu and the function corresponding to it is tv. The distance between tu and tv is basically less than the distance between u and v. This is what is called as contraction mapping. Clear? Let's proceed to Banach fixed point theorem. Suppose U is a Banach space and P is a contraction mapping. There exists an unique P star in U such that PV star is equal to V star. What does it mean?
P star is a fixed point.
Yes.
P star will be the fixed point.
So can I say T has a fixed point? Is it the same? Am I correct? Can someone explain me what I have written? Yes, come on. Yes.
Yeah, if we start from an arbitrary function v0, and we continuously apply this t and apply it sequentially, then we should converge to v star as n tends to infinity.
Yes, you are correct that if I'm applying, suppose V naught, apply T, suppose I get V1, then apply V1, I'm getting V2, and then I'll end in V star. Is it what you said? Is it the same here?
Yeah,
What is this? TVN, V0, N is equal to 0. I'm getting Vn plus 1, then applying again, and then we'll basically end up in V star here. That is what is written here. So now let's take it the same example. So for the first time, action 1 is performed. Can someone define, so I can say, if action 1 is performed means pi 1, what do you mean by action 1 is performed? What is what I have written here by inferring this? When I'm saying action 1 is performed, then why I'm writing, like, what is this basically? What I'm doing here?
When we apply action 1, we go from state 1 to 2 and we get reward 1.
Yes, you are correct that when we perform action 1, then we are going to state 2. And what I'm saying is I'm defining the policy here that action 1 is performed, like pi 1 is equal to A1, pi 2 is equal to A1. This means that I'm defining the policy. Like, is it correct? The policy of pi 1 at the state 1, I'm performing A1. I'm assuming that policy is this. Now, what is V pi of 1? Now only we wrote what is V pi. We wrote that V pi is R pi plus gamma P pi V. So what is reward here? When we are performing action 1, we are in the state 1. What is the reward?
1.
1. What is the probability to go? Okay, we are taking here gamma. Okay, let's take probability as deterministic only. So here, V pi of 2, same. 1 is the reward, gamma, V pi of 1. Can we solve this? Let's try.
Yeah, we have 2 equation, 2 variables. So
Is something wrong I'm doing? So, is this correct? I just substituted the value of V pi of 2, 1 plus gamma V pi of 1, and then open the brackets, shift it to that side to get the value of V pi of 1. Any doubts? Any doubts? What about V pi of 2? If I'm in the state 2,
It will be the same, right? First, again, we're getting one reward
but what is the reward here?
plus one.
Hmm?
Again, one reward we're getting going from 2 to 1.
V pi of 2, I mean to say, when I am performing action 2. If I'm in state 1, what is the reward?
Minus.
So basically, minus 1 plus gamma V pi of 1 half. And then same similarly we'll solve for this, substituting the value of V pi. Taking gamma square V pi to the left hand side. Can I write it like this? Then I can write. Is it correct? Why no one is responding today?
It's correct, madam. We're just wondering that how this convergence V pi of 1 and V pi of 2 are are getting converged, right? That's what we're trying to prove.
Yes, yes. We'll try, we'll learn more things as going forward. I think no one is responding. I should start with an example to make it more, I can say, interesting, the class more interesting, the example which I have done. Okay, let's do this contraction thing and then I'll start with the example thing. So that let's make the class interesting and interactive one. So what is contraction mapping? As you told that the functions of u and the points are more closer than the points itself. That is what it means. So u and v are some distance apart. When we apply t on both of them, they'll be closer than what they actually are. Am I correct by saying this statement?
Yes.
Now, so Let us go ahead. Let us first use this triangular inequality and understand how the things are going basically. So before going to triangular inequality, what is Vn plus m? Can I write it as Vn plus m minus Vn plus m by 2 plus Vn plus m by 2 minus Vn. So what I have done in this point, simply added and subtracted with this. I can add and subtract. Now, can I write it as this is the important point. I'm just elaborating it so that you can understand. Otherwise, this will be given directly to you. Nothing I have done, just added and subtracted this Vn plus m by 2. And then what is triangular inequality? Can someone tell me? Come on. We have done in the last lecture about triangular inequality.
So this right hand side is greater than the first the above equation right hand side. So
that, yes.
So that is greater than the left side also.
Yes. Basically, norm of x of y, I can say that is, can I say this is the triangular inequality? This is basically triangular inequality where I say that norm of x plus y is less than equal to norm of x plus norm of y. So that is what I have applied here. Done nothing, just added and subtracted one term, and then I can say by the triangular inequality, by taking this, by splitting this, that this will hold here. Let's proceed. So let us say that there are 3 points in a space. Let it be Vn, Vn plus m, Vn plus m by 2. Okay, that we have taken only. Now, I have done nothing, just added and subtracted this term. That was just, I'm showing the same only. And then again, that same thing I'm doing, applying the triangular inequality. Now again, I can do the same thing. This is very important. In the lecture, actually, they have done like for the one step only. Maybe some people can't understand. So that is why I'm doing this. Now, can someone tell me what I am doing here? Okay, I'll proceed.
After each step, we are considering the distance, right?
Now, what I'm doing is, what I'm saying is, just I'm adding and subtracting same, then I'm doing the triangular inequality. The same thing I did with this Vn plus m, Vn plus m minus 1. Then I'm doing with this Vn plus m minus 2. I tried to split it so that you can understand what is happening behind the picture. So on till Vn plus 1 minus Is it correct? Please stop me. Now only if you are having any doubt, I'll explain in detail again.
Yeah, it's correct.
Now I can write it as summation of k is equal to 0 to m minus 1. I'm writing this m Vn plus k plus 1 minus Vn plus k here. Let me tell you again so that no doubt should be there. Just using triangular inequality. Triangular inequality is this. This is what we have. This is what we have. I'm just adding and subtracting the same term here. And due to triangular inequality, I can split it up and say that this is larger than this. Basically, the norm a plus b or x plus y is less than norm of x plus norm of y. That is what I'm actually writing here by splitting it up. Similarly, I can do for m minus 2 itself. And then I can do till I can split this basically like this itself. That is what I'm showing here. Then I'm taking it as k is equal to 0 to m minus 1 and writing this equation. Basically, this equation is equal to this. Is it fine? Okay. Now, we learned in before only about the properties. Now, how we came to this? Yes.
From the above one of the equations that we are applying the operator T. Yes,
That.
contraction.
By this, we are writing that Vn plus k plus 1 like this. That is what we are doing here. So now I can write it as by taking it common lambda so can I say it is a GP?
Yes.
And apply the formula A 1 minus r power n into so as n and m becomes larger, it becomes smaller and smaller. What is Cauchy sequence?
The difference between 2 points after some point n becomes less than epsilon.
So can you relate it with this?
Yeah, so it is decreasing. So it will, after many contractions, it will lead to a Cauchy sequence.
So can I say Vn is Cauchy? I just want to ask, is it everything like, are you getting it? Like, I'm getting very less response from a person only. Like, are you getting the whole thing, which I'm explaining how I get it to this? Please stop me. I'll explain again. We'll go through the question again.
Madam, just 1 minute. No, without getting into the derivation, can you just explain? Because the whole concept. What is the big purpose, and is it to prove convergence? Just in few lines. In a qualitative way.
Basically, we are saying that it is a Cauchy sequence. Cauchy sequence means like if you have to Cauchy sequence means sequence like after some point it will become like elements will come closer and closer to each other after a certain point. That is what we are trying to prove here. That is what we did, and then we applied the triangular inequality here by adding and subtracting the same terms here. Like we are adding and subtracting, this is the same term, like this was given to us, this is the same term which we add and subtract, then apply triangular inequality, which means that norm of x plus y is less than norm of x plus norm of y. That is what we did, and we came up to this part, and then by GP we came up to this, and then we are saying when we increase the value of n plus m, n and m, then this whole sequence will become smaller and smaller after some point. That is what Cauchy sequence is, that after a certain point, the elements will come closer and closer to each other. So you got the whole picture?
Yes, ma'am.
And now V here is still value function or some any point?
Yes, V here is the value function.
Okay, so the difference between value function will decrease because the number of steps are decreasing. So return with the discount part of return will be less, right?
Yes. Can you repeat like what you said, that the difference between them will decrease?
Yeah, because earlier, like let's say we're taking from the first step, we are taking return of 100 points, and after a large number of sequences, we are taking return from 10 points only. So that is why our value function will decrease.
After some point we are close to the convergence, we can say that it will decrease. Am I correct by saying the statement? Yes. Should I go to the proof again, or should I solve that example, the last one, so that some interesting things should come, because today class is... Okay, let's start with the example, then I'll come again to the proofs. Is it fine? Okay. So let us say machine can be in working or non-working state. Have someone tried that example which was given in the Slack? Everyone is on the Slack, or if someone is not there, you can write on the chat and I can share the link. Okay, the machine can be in the working or non-working state if working, operating machine incurs zero cost. So what are the states here?
Working and not working.
Working and non-working. So if it is in the working state, the cost is basically zero. What is the difference between cost and I can say reward? Is there a difference, or are they same?
We can say cost is like negative reward.
Yes, you are right. And on the other hand, if it is a non-working with one time period, it incurs cost of, should have written it before only, 3 units. If machine is replaced by a new machine, with cost of 6 units stays in working for one time epoch. Working machine can transition to non-working with probability 0.3 if system needs to be operated for 4 total time epochs with an objective of minimizing cost, formulate MDP, and provide optimal policy.
Initially, do we have working machine or non-working machine?
It can be working as well as non-working. We have to take both the cases here. And 4 epochs, which means that I can say that J of 4 or like value function of 4 is basically 0 here. Okay, let's say I'll give you 10 minutes break. Already it's 1 hour. So let's try to solve this question in that 10 minutes break. Then we'll meet at 7:10. Is it fine? Just try give a like fine.
Can you specify the action? I'm not able to.
Okay. What do you think? A machine can be in working as well as not working state. Can I say the state is working or not working? Okay, it's correct. If operating machine incurs zero cost, and on the other hand, operating a non-working machine incurs 3 units, which means that if it's working, we are getting a cost of 0. If it is not working, it is getting a cost of 3. And if a machine is replaced by a new machine with the cost, we are getting a cost of 6. Can I say that the action are either we have to continue or either we have to replace?
Yeah, okay. Cool.
Now the probabilities are given to us from working to non-working, working to non-working. Obviously, working to non-working is 0.3. So working to working will be 0.7 here. As the probabilities add up to 1. And then let's try to solve it. So we'll meet at 7:10. Till that, sorry. So you got the question? Or should I solve?
Hello.
Yes.
Yeah, so got the question, but how do we accommodate this capital T equal to 4, the number of epochs 4? That is somewhat not clear. I have to copy pasted whatever I understood, all the
Uh-huh.
states in the chat,
States are okay.
states actions,
Are
in the
okay.
states actions,
Actually,
rewards.
every time epoch we have to calculate. Like at t is equal to 0, what is the optimal policy? At t is equal to 1, t is equal to 2, t is equal to 3.
Yeah.
So basically,
So,
we'll
so
start
how do
from.
we so do we need states at equal to 0, 1, 2, 3?
So initially for the fifth, like we'll say that value function for the last is basically 0 because we are doing till 4 time epochs. So fifth is basically 0, and then we'll put the values in that value function, and then we'll calculate it.
How do we accommodate time in the Marco state transition diagram? How do we
Okay.
accommodate time in
Okay.
state
I'll do it.
transition diagram? Yeah. So could you draw state transition diagram?
Yes, I'll do it. So everyone is here. Should I start? I gave the time 7:10 maybe. So let's wait till 7:10, then I'll start
Okay.
because maybe some are not present here. They will wait for 7:10. Okay, let's start. Am I audible? Everyone is there. Should I start?
Yes, please. Yes.
So now, as we know, state is basically working as well as not working. We have two states. We have two actions. Either you will work or operate, I can say, or either replace. Continue, or I can say here, continue working or replace. We have two actions here. Now, probability of going from working to non-working is 0.3. And probability of we are in the state working and we are in working itself, obviously we can say that the probability is sum to 1, so it is 0.7. And the information, other information which is given to us is that we'll run it for 4 total time epochs. This is what the information is given to us, or we inferred the states and actions.
Madam, in some books I use the word episodes. Is the same? Epochs and episodes?
Yes, yes, yes.
Okay, okay.
Okay. Now, we'll 4 time epochs, we'll say 0, 1, 2, and 3. Let us take the notation as J star rather than V. Let us say I'm in working state. Then what will happen? Two things can happen. Either I'm currently in the working or either I'm currently in the not working. We don't know the initial state as well. So suppose I'm in the working. First, we'll come to not working as well. So what is the cost of like working and still there are two actions which are performed, either the continue action or either the replace action. So what is the cost if I am in the continue? If I'm continuing,
0.
0. Plus, what is the probability of going from working to not working to working? First of all,
0.7.
0.7. Where I'm landing, J star of 4.
Working. Yeah. Yes, sir.
And what is the cost? 0.3 if I'm going from working to non-working. Till now, this equation is cleared. I took the action continue. The cost was basically, if I'm continuing, that is 0 cost. 70% of time I'll go from working to working, and 30% of time I'll go from working to non-working, and I'll land in J star of like the state 4 itself. Till now, correct?
Yes.
So if I'm replacing, then what is the cost?
Why to replace? It's working machine.
It's working, but we are not saying that we'll
There is-
not in that line that it's working machine. Sometimes you have a phone and you are replacing it and it's working.
Okay, I see. Okay.
So we have two actions. That is what it is given. We are saying that either what is the optimal action? We have to check it from that. It's
Okay.
got it. So what is the cost of replacing?
-6.
-6.
So
-6.
-6, I'm taking it cost, so 6. If I'll say reward, I'll take -6. And
Okay.
I'm taking min. Why I'm taking min and +6? Can someone tell me?
Can you repeat
Why?
your question?
Why I'm taking min here?
Because we have to minimize the cost.
So I'm taking either if I have to take max, then I'll take -6 because I'll consider it as a reward. So let us take it as cost only and take it as minimum. I have to choose the minimum one. So replacing is 6 plus if I'm replacing it, I'm in the working state where I'll go
Working.
in the not. If I'm in the working state, I'm replacing it where I'll go. Like
Working.
Huh.
By replacing always, we will go to working.
Okay, wait a second. Something is wrong here. Okay, so the probability of it is 1 basically, and then I am saying that this is 0 here. So minimum of 0 and 6. So I can say 0. And here, what is the optimal action here performed? That is continue. So I can say if I'm in the working state, I am the third time epoch, I have to continue. Am I correct?
Yes.
Yes.
So now the other is if initially I'm in not working state. So what is the cost here?
-3. If we continue, that is -3. Oh, that is 3. 3 because.
If I'm continue, I'll not working state, I'll end in this only. Am I correct? If I'm continuing, I'm saying that I'll end up in non-working only if I'm in the non-working state. And replacing the same as that. So what is the optimal option, action I have to perform? I have to continue if I'm in non-working as well. Don't think that intuitively that we are in non-working, we have to replace or in that line. Let us go in the line of this, what they are saying. So if I'm in the third epoch, let us say if I'm working, then the optimal action is continue. If I'm in not working as well, sorry. And also, the optimal action is continue.
One thing, why did we start with the third epoch but not
What we have taken in the question that there are total 4 time epochs.
Yeah, but why did we start with the 0th epoch?
It is basically we are taking it as bottom up approach because we know J4 is equal to 0. If okay, I'll start with the J0. Okay, let's suppose J0. Then minimum of 0 plus. Wait a second. Wait a second. Let me switch up this. Sorry for that disturbance. So I know that I'm in the 0th, okay, and where I land at J1 with some probability. Do I know what is J1?
No.
Then I'll go to J1. Some reward. Do I know what is J2?
No.
Then I'll go to J2. Then do I know what is J3? No.
No.
Then I'll go to J3. Then I'll find J3 because I know J4 is equal to 0. And then I'll go
Yes.
again. So it's better that I should follow bottom up. Is it fine now?
And is there a case where we take like from the 0th index, or always we should go for bottom?
In this case, a value iteration, we basically go from bottom to up because we know that we have to end here, suppose. I know that I am ending here. So let us go bottom up approach because I know the second last stage I'll start and the last stage, then I'll come like to the initial state as well. Okay, we'll try to solve more and more example and then check is there a possibility that we can go from top to up. Basically, we go from bottom to up only because we know that this is the if we know that this is the end state. Or the example, suppose I gave you, if you remember that usually I give you about the example that suppose the battery is there, suppose, okay, I'll give you the example in the Slack itself, and then we'll check by some examples, solving many examples of the code and this, that how these are working. You got to know why we are performing bottom up here in this particular example.
Yeah, yeah. And if it would be infinite MTP, then we will take from start.
If it is finite MDP, can I say that it will be bottom up approach? Okay, we'll see the more example and then we'll come to a conclusion whether it is true or not. But for this certain example, is it correct to go from bottom up?
Yes.
Okay, now we have solved this J star 3. We'll go for J star 2. And then again, we'll solve like, okay, minimum of what is the cost. Now, again, we are suppose at working state. Then what is the cost? 0, basically. In the working, 70% of time, we'll basically, I'll write it and then please can someone explain what I have written?
Yeah, these were our values for J3 for working or not working. So for working, we took the zero cost, and for not working, we chose the 3 cost.
You got it? Why we chose 3 cost? You got it? Why we chose this 3 cost?
Yes, yes.
Basically, we got it from the last example that if we are in not working, then we'll go to like the cost incurred is 3 basically. That is what is J star of 3 basically. I can say it as J star of 3, which I got it as 3 only. Is it correct at non-working? Should I proceed?
Yes.
Yeah, yeah.
So if I'm replacing it, then okay, there is a trick here. What they're saying is, if you are replacing it, actually it should go to working only. Replacing means doesn't okay. What is here is that if you are replacing it, you are going from working to non-working, though it is not a practical scenario. And if you are in non-working, you will go to working. Though it is not a practical scenario, we'll go from working to working itself. If we are replacing, we'll not go to non-working. But we are saying that we are replacing from working to non-working. Then what is the cost here? Can I say 3?
Yes.
So 0.3 into 3, that
Could you repeat this working to not working if we replace?
replaces, actually it should be working to working. That is what I'm thinking is. So the assumption is like if
Yes.
we are working, we are replacing it to non-working. Or let us take it as working only.
If we are in working state and replacing, we'll go to working, right?
Working. Yes, you are correct. Let us take it as
Yeah.
that only. And let us take it as that only. So can I say it as 6 here and here?
0.
Is it correct now?
Yes.
Hmm.
Yes.
Yes. So now, can I say that at second time epoch, when we are in the working state, then I should continue being in the working state. I shouldn't replace basically. So this other action is if I'm in the not working state. So if I'm in the not working state, the cost is 3 here, and the probability of being in the not working, I got it as 3 in the earlier one. Then replacing 6 got it as 0 earlier. So I can say that. So what should we do here if we are in non-working state?
Equal probability of choosing.
So either we can continue or we can replace also. So it has the equal probability of doing so. So now coming to time epoch 1 here. So if I'm in the working state, being in working 0, 70%. So what is the probability? Can someone tell me?
0.9.
0.9 plus 30% of time not working 6,
6.
replacing 6, cost is 6. Now what is the probability? Working
0.9.
value
0.9.
cost.
Yes, cost actually I confused. So it's basically 2.3 and 2.43 and 6.9. 63. So we should continue basically.
Why it is 0.9? It is 6, no? J star 2, even not working, 6.
Here you are asking.
Yeah, there. Yeah. J star 2 is 6 when not working.
It is working basically.
Working.
And we are
Okay.
replacing. So
Okay.
working and replacing, we'll end up in working as we are assuming that. So 0.9.
Okay.
So not working. Now coming to not working case, then the cost is basically 3. Now it is 6 basically, I can say. Replacing is 6. And if we are replacing it is 0.9. So now what is the optimal option we should do in time epoch 1?
Replace.
We should replace. Now at time epoch 0 basically. So working 70% of time. What is the probability? 2.43. Sorry, cost. I was confused. 30% of time. I'll end up in non-working state, which has the cost of
6.9.
6.9. Replace working to working.
2.43.
2.43.
2.43.
.43. We should continue only. That is the optimal option. Now coming to if we are in non-working state. Cost is 3. What is the cost here in the non-working state?
6.9.
6.9.
And here is 6. Now what is the cost of replacing? 2.43.
2.43.
So 9.9 and 8.43. Everything clear? second. Let me put the iPad on charging. So now can I say I came up with the policy saying that okay, what is the optimal action if I'm in t is equal to 3 and action I'm in the working state? Can I infer? Continue.
Always it's continuous.
Continue. And here it was continue or replace. You can do anything. Is it fine? We came up with the policy. Any doubts in this question?
So there are actually 8 states, you want to say? There are 8 states.
We are having 2 states, but
In general, it's because the time has come in picture.
Yes.
Are there 8 states?
In general, we'll say we are having 2 states only, but that state, I'm in a particular state, that state will be changed at the other time epoch. Yes, then we can say that we are having the 8th state. Like that state S is basically at one time epoch we are having only 2 states only, working or not working. Then other time epoch we changed into S dash, that is working or not working. Then we changed into other one. 4 time epochs we are doing. States will consider working and not working at every time epoch, we can say.
Because we are computing 8 values and 8 policy 8 steps in the policy.
Yes, in that sense, we can say that we are having the 8 like that. But states overall we'll consider at one time epoch, I can say 2 states are there.
At one time epoch, it's fine. Yeah.
So, is it fine? Should I proceed? How was the example? Any doubts?
No, it's good.
Okay. So let's proceed forward. So what was the what is the limitation you are thinking that it can be in the problems like this?
If there are a large number of it goes for a long time, then you will have.
And it was just a 4 time epoch. And if you go for more time, the state will obviously, as we are saying that there are 8 total, we are saying that but that will explode and obviously it will be computationally very complex to handle that. So can I say that it is a limitation here? Should I solve these type of examples in the class, like coding or you want to go through the proofs and all? Or coding examples or
Which
these
part is more important?
Okay, you want this type of examples or coding examples I'm asking, or the proofs part?
No, we don't know because we don't know what will be more important.
Madam, this kind of examples will give us more understanding of concepts rather than proofs.
Okay, I'll try to solve proofs as well as in each class I'll solve one such example so that you can get more intuitive understanding. As the proofs are also solved there also, though I'll solve the proofs as well because many of the students are having doubts in those, like sometimes in the proofs and all. But I'll try to take one example in every class each time. And I think the other thing is taking the coding examples. If you want, then I can also include the coding examples as well. So do you want that that should be included? Then I'll give you the coding questions today, 9th or tomorrow only. Then we'll solve those questions so that you can also go through it. You can solve those questions in the next class. Or we can solve these type of numerical questions by hand.
Because, madam,
both questions. So, like few
Yeah.
both questions.
Yes?
You can give both type of questions.
Okay.
no, basically what I feel, madam, this once you understand the logic and formulation of the equation, coding is an automatic. So I think better is I'll illustrate with example the process. That is better.
Okay. So I'll more go with the process. If someone wants the coding question, then we can do that. And more, we can go with these examples.
You can discuss example in class and give coding part as big homework. So that
Okay. So can you do this code as a homework part?
Yeah,
Can
okay.
you
We can try.
Okay, let's go with the part where we left. So we proved that Vn is Cauchy sequence. I thought to switch to example because no one was responding. So I thought, okay, let's make the class some interactive one. I was thinking we'll take at the end, but it's fine. So I'll try to add every time some example, numerical example, and give the coding question as an homework assignment. So now coming to the convergence proof. So we know that TV star basically it is a fixed point, and basically V star is truly a fixed point. Then it will be basically 0, otherwise it will be greater than 0, I can say. Now let's try to do that convergence proof, and let's try to implement the triangle inequality property here. Can someone help me? Wait a second. First, I'll write it and then help me with that. As we have done it many times, applied triangular inequality many times. Can someone help me now? I think I have done some mistake here.
should be less than or equal to. First equation, it should be less than or equal to. So
Yeah.
triangle inequality.
So now I can say this. Is it fine now?
Yes.
Yeah.
So what is this? If it is a fixed point, like what is this?
This is the convergence point. This is where we converge.
Is it correct? Can I write B star?
Yes.
Okay. Wait a second. TV star. Let us write it as this. Can I write it at like this as this? By the, as we know, is this same? We earlier said
Yes.
that Banach fixed point theorem. So let us write it as like this. Through like we defined it earlier. Now let's write TV star is equal to V star by the fixed point. And similarly for this,
We cannot write TV star equal to V star because we have to prove that. We are proving that. And how can we write it over there?
you're
We are
correct
proving
here.
TV star is equal. Yeah, so we can't. Yeah.
You're correct at that point. Wait a second. Something is wrong.
So this is contraction. TV star minus TVN minus it is a contraction. So it's a lambda V star. Lambda we can write down. TV star
Okay,
minus
okay,
TVN minus lambda.
okay. You are correct. You are correct. Now is it correct?
Yeah.
Because we are proving that TV star is equal to V star. Like how can we write it at that? So we are basically writing it as lambda V star minus Vn plus 1. Now, now can someone tell me how we'll proceed further? We
Can we
like
take like n minus 2 and minus 3 and we again take GP?
No,
can I give you a hint that
because
we did that Vn is Cauchy? What we
yeah,
infer
main
from
is
that?
yeah.
Vn is Cauchy. We have proved now only. Can I say that Vn basically will converge to like Vn will converge to V star or
Yes.
when the limit n tends to
As
infinity,
n
then
becomes
Vn will
large.
tend
Yes.
to V star. Is it fine? So
Yes.
can I say that this value will be equal to 0?
Yeah.
Yes.
Yes.
Now what about this?
That is
That will
also
also
zero.
be 0.
Yes. This will also go to 0?
That will be also zero.
Yes.
Yes.
Now we came to that part. We are saying that V star minus Vn
TV star. TV star is equal to zero. TV star minus V star is equal to zero.
TV star minus V star is equal to
For large n.
if the I can say if n tends to infinity.
Yes.
Is it fine? So
Yes.
that is what we are proving here. Now, coming to the uniqueness thing, or okay, let U star let us go to the contraction thing. Okay. Proving of the contraction, U star and V star be two fixed points. What is this equation?
It's contraction.
Contraction only. So when will be T? When will this happen? When will this happen?
Lambda is 0 to 1.
What if lambda is equal to 1? Can this situation happen?
No, that will, okay, that will be when it's fixed. That will remain same. Okay.
So if lambda is equal to 1, is it true or not? That this one is true or not? That it is
Yeah,
a
it's
fixed
true.
point.
It's true. It's true.
Sure.
No.
Like, it
Why
can
no?
be and cannot.
Why can be? Why cannot be? Why no?
Because we're saying the distance remains same. So may if it can remain same if the points remain same, or it can be if points change but still distance is same. So two cases can be there.
Can someone else also can try? So
If
if
T is
lambda,
contraction operator, lambda has to be less than 1.
can I say lambda shouldn't be 1 here?
If T is contraction, it should be less than 1.
Okay. Yes, lambda is less than 1. What about if lambda is equal to 1, then it will satisfy or not? If lambda is equal to 1, obviously it will not be a fixed point because it will be like this. Whereas they are equal here. Basically, there, if lambda should be less than 1 or it shouldn't be basically equal to 1, I can say. Is it clear? Okay, let's move forward. Let U1 be in a V space, basically. Applying the L pi operator on U and then on S. Same equation. Can someone explain this? This is simple.
Bellman operator.
Yes.
Simple Bellman operator. Bellman operator.
Yes, yes. We are getting a reward, summing it like going from probability, going from that and ending up in the U cost, terminating cost. Simple that thing. Now, taking that, let L pi of V of S be greater than L pi of U of S. I can say L pi of V of S minus L pi of U of S is less than equal to R pi of S plus gamma sigma T pi J Bj minus R pi of S plus gamma T pi Is it fine till now?
Yeah.
Yes.
Can I say it is equal to gamma J given S Bj minus Uj?
Yeah.
I'll write the next step and then we'll discuss about it. Wait a second. Someone explain me how we get it through this. What is this basically? What I'm writing it? How I got from this step to this step?
So we are taking the we are assuming that this is like a element-wise subtraction.
Yes.
This
Right.
should be greater than the max difference. So lesser than the max
Let's
difference
open it.
possible.
Okay. What
Yeah.
is this?
And this is the infinity norm of the max difference or just the maximum value of the of this term.
I can say it is a max norm or the infinity norm. So basically the different component wise difference or the element wise difference, it is basically lesser than the max norm here. That is what I'm writing here. Is it fine? So what will be this value?
1.
Yes,
1.
1. Basically we'll sum it over all j and we'll get the value as 1 here. So I got here gamma b minus mu. Can I say
Yes.
what do I mean by this basically? Can someone explain?
We have proved that when we apply the operator L by 2 points B and U, the distance between them will decrease by a
Yes.
factor of gamma.
So, okay, we'll end the class from this only because the next topic, if I'll start, that will not be completed. Till now, whatever the proofs are done, is it fine? Today's
Yeah.
example was okay.
Yeah.
Yes.
So, in the
So
next class, yes. Yes, someone was speaking.
yeah, I had a question. I know if you haven't covered that. So I think for this week, sir had talked about L and L pi. And is the main difference that for L we don't know the pi, we are taking the max pi, and for L pi the pi is deterministic and we are operating on a known pi. Is that
Yes,
correct?
yes.
Okay. Yeah.
We'll talk about it in the next classes, the same what you are talking about.
Okay. Okay.
So we'll continue this in the next lecture and I'll try to come up with the more examples as today. So we'll try do that value iteration, policy iteration. Then I'll come up with both of the examples as a coding example as well as the numerical example as well, so that we can try to understand the intuitive thing behind those. Any doubts?
Next class is Saturday, right? Next Saturday.
Yes, next class is next Saturday.
Not tomorrow, right? Tomorrow's class is postponed.
Yeah, that is
That's on
on
Friday.
Friday. Yeah, Friday.
Yeah.
Friday.
That
Yeah,
is on Friday.
Friday.
So
Okay.
the Abhijit session is on Friday because yeah, it was
So
there
it will be
postponed.
on Friday, Saturday, Sunday. 3 days
Yeah.
classes will be there.
Mm.
Hmm. So I hope that you all will send the coding examples in the the coding example of today one in the Slack group. Any doubts? Thank you, class.
Thank you.
Thank you. Thank you so much.